Hi, this is our presentation of BECN's final project, in which we'll talk about the determination of the dynamic friction coefficient of rubber wheels used in a mini sumo robot. As most of our project group participates in Tamanatech's robotics team, we decided to study a subject that would unite every participant to this scientific knowledge. Given that, our object of study was the mini sumo's robot Podolsky. The sumo fight consists of two adversary robots facing off against each other in a circular arena, the dojo, with the main objective of pushing the opponent out. Knowing that, we questioned ourselves. How much of a difference does the friction between the dojo and the wheels have in the development of the sumo fight? And could it be a turning point when it comes to achieving better results? With that in mind, we started an experiment whose objective is to measure the influence of curation time in the friction coefficient and force variation that the robot applies over the opponent during a fight. We analyzed the curation times of 3, 5, 7, 9, 11, 14, 16, 18, and 20 days and used the following methodology. We produced the wheels with an elastomer-based silicon, together with a catalyzer. With the passing of days, the silicon was able to mature and become more rigid. Here are some photos of the actual fabrication of the wheels. First, we put the elastomer in the metal mold, then we waited for it to solidify, took it off, and waited for the desired curing times to use it in the tests. To use the robot in the tests, it was necessary to make adaptations with a system of supports and strings, with the objective of lowering the influence of dissipation forces in the measuring of force and traction produced by the robot. Here we can see some of the footage of the production of the supports used in the robot, which was done by a 3D printing machine, and also, as it can be seen in this footage, we had it manually attached to the robot by André, one of our group members. To take the measurements, we utilized a mechanical dynamometer tied to the adapted supports by a string. To control the robot, it was necessary to compile a code that would allow us to command it to follow in a straight line by remote control, and to obtain the data, we filmed the tests in slow motion. And for that, we used the following configurations. With the tied dynamometer position and the robot ready, we started to move Podolsky forward initially with 11.7% of the velocity capacity, waited for the coil to stabilize, and then increased it to 27.4%. We repeated this procedure 5 times for each curation time tests and filmed each one of them. The collected data was further analyzed and we arrived at some graphs that better describe the observed behavior. A few of them are presented here. In the first one, which represents the 3-day curation time, we have a different curve for each test, with the passing time in the x-axis and force in newtons in the y-axis. It can be seen that we have a clear distinction between the dynamic and static frictions and that the behavior here is well contoured. In the second graph, on the other hand, which is representing the 20 days curation time, we have a much less defined behavior for all of the curves, and so it's not clear whether or not we have dynamic or static friction in each part of the test. By taking these values and proceeding to do the necessary calculations, we were able to arrive at some specific numbers for the friction coefficients and put an end to our quest in searching for the best curation time. And as it can be seen, we have a higher and consequently better for our applications dynamic friction coefficient and overall force around the 9 to 11 days curation time mark. Which leaves us the conclusion that, yes, the curation time has an influence in the capability of the wheel exercising its maximum potential, and it may as well be advantageous in a competition scenario. We also had some failed procedures when we were trying to come up with the best way to measure everything for the experiment. For example, here we were having our try with using a different wood surface for the friction measurements, which ended up not working out because it wouldn't simulate in a good way the most important factor, which was the floor of the fight's arena, and because initially we thought about tilting the plank to measure specific friction coefficients, but that was overcomplicated and it wouldn't be able to answer our questions. And here we tried to take measurements in the floor, but soon we realized we would have the same problem as the wood plank, which would be not simulating the dojo's floor adequately. This is our project in a nutshell, and we are grateful for your attention.